3.1. So we're going to classify each alkyl halide below as being primary, secondary, or tertiary. And you go, oh my goodness gracious, what is going on here? How do I even consider that? This is easy. Very, very easy. I'm going to give you the prescription for doing this as you're studying this. First, you want to identify the leaving group. We'll do this in orange, right? Because we've been identifying leaving groups with orange. So first, we're going to identify your leaving group. Okay, so we look at our first example that's provided here. Move this down. All right. So we look at A for a second here. Let's identify the leaving group. Want to guess what the leaving group is? Take a guess. BR. Here you go. Your leaving group is BR. All right, let's take a look at B. Where do you think your leaving group is there? What do these all have in common with each other? CL, right? That's your leaving group right here. Let's think why for a second. Why is CL going to be your leaving group? Well, look where BR is on the periodic table. It's element number 35. Then look at chlorine. It's right above it, element 17. So the two of these are going to be, using periodic law, they're going to be very similar with each other. This is your leaving group. Now, Cl comes with an added bonus that it has a fairly high electronegativity relative to carbon, so it actually causes carbon to be slightly more polar or partially positively charged. That may actually influence the reaction rate, but we'll talk about that later on. Okay, C. What's our leaving group now? Br. And then our last one, D. What do you think our leaving group is there? How do you know it's I? Because look, we're on the periodic table, are we? We're in group 7, right? Just below Br is an I. All right, so we've identified the leaving group. Second step, just like the song, the leaving group's connected to the electrophile. I made that up. The leaving group is connected to the electrophilic position. Br, so look at where Br is in A. We want to highlight what's touching Br. So we put, boom, a blue right there. That's your electrophilic position. Look at B. Cl is touching that carbon right there. That's your electrophilic position. Br is touching this electrophilic position right there. Iodine is touching what? This carbon right here, right? All right, so we've identified the leaving group. We've identified the electrophilic position. Now we have to determine, is the alkyl halide primary, secondary, or tertiary? This is our third step. We ask ourselves, how many carbons are touching the electrophilic carbon? Oof, let's try and respell that. Touching. That's where our answer is going to be. Okay, so we look at A, and you say, how many carbons are touching the blue carbon? This is simple. Ready? 1, 2. So this makes this what type of a alkyl halide? We call it a 2' Rx, or more specifically, we call this a secondary alkyl halide. All right, look at B. How many carbons are we touching? 1. So this makes this a primary, right? And so we can just symbolize that by saying it's 1, and then that degree symbol, Rx, to mean a primary alkyl halide. All right, C. Tell me about C. Which is what? Means what? Starts with the T. Tertiary. Excellent. 3' Rx. All right, and then D. Love this one because I get students tripped up on this one. They see a lot of junk in this and they go, but if you stick to the basics, the fundamentals, you'll know what it is. 2, it's secondary. I said primary. Secondary. It's exactly the key here. This is a secondary alkyl halide. And this is a very important skill to know how to do when you're working through these substitution reactions, is you got to know the difference between a primary alkyl halide, a secondary, and a tertiary, because that actually will influence What will that do? That will influence the chemistry here. Actually influences the reaction rate.